Hello students, I am Dr. Parin Sheikh from LG Institutes of Applied Sciences. This is my third video lecture on group symmetry. In this video lecture, we are going to discuss what is point group and point group of the different molecule. This is very important topic. So let's start. In last video lecture, we have discussed about symmetry operations and symmetry elements with different examples. Now, in this video lecture, we are going to discuss about classification of point group. Each molecule has a set of symmetry operations which define point group of the molecule. Classification of the point group is based on symmetry operation that molecule has. First, linear molecule. If our molecule is linear, so the point group would be D infinite H or C infinite V. If molecule has multiple higher order axes, then point group become tetrahedral or octahedral. If group of low symmetry Cn absent in our molecule, so point group will be C1, Cs, Ci. If highest order rotational axis Cn present in the molecule, so it divided into C type which possess Cn, Cnv, Cnh point group, and second, that is D type, in which Cn perpendicular and C2 symmetry operation present, which has Dn, Dnh, Dnd point group. Let's discuss one by one. First, linear molecule. If the molecule is linear, so next, is there any sigma h and I present? If sigma h and I present, the point group will be D infinite H, and if sigma h and I absent, so the point group become C infinite V. Let's take one example of the CO2 molecule. This is structure of CO2 molecule. CO2 molecule is linear. CO2 molecule possesses C infinite rotational axis. Second, it has sigma h, and third, it has center of symmetry I present. So these are the symmetry elements for the CO2 molecule, and the point group become D infinite H because it has sigma h and I present. For the better understanding, let's take some another example for the D infinite H point group. H2, Cl2, Br2, O2, N2 and ethylene molecule. This molecule has this symmetry elements. Next, let's take one example of HCl molecule. HCl is linear molecule which possess C infinite as rotational axis. It has one sigma V. And there is no center of symmetry present in case of HCl molecule. Now these are the symmetry elements E, sigma infinite, E, C infinite and sigma V. There is no sigma H and I present in our molecule. So the point group become C infinite V because here sigma V present in our molecule. Now these are the example for C infinite V point group. CO, HCl, HBr, HI, HF and N2O molecule. Second, multiple higher order axes. If molecule has multiple high order axes, so either 3C4 or 4C3 present in our molecule. If 3C4 present, so the point group will be octahedral, and 4C3 present, so point group will be tetrahedral. Now understand this by taking example of methane molecule. Methane molecule has this symmetry elements, so the point group become tetrahedral. It has improper rotational axis 3C2, 4C3. Let's discuss one by one. First, S4 axis, improper rotational axis. Improper rotational axis means first rotation, then reflection. It is structure of methane molecule. First, we will apply C4. This is second orientation. Now, then we will apply sigma H, reflection, and we get this orientation. This is S4 axis present in case of methane. Total 3 such S4 axes are present. Second, this is structure of methane molecule. Here we are taking methane molecule in a cube. First we will see C2 symmetry operation. Total 3 C2 symmetry are present. This is first C2 symmetry. Second, this is C2. And third, this C2 axis are present in our methane molecule. Next, dihedral plane. Dihedral plane which bisects the angle between two C2 axes. This is dihedral plane present in the methane molecule. Next, C3 rotational axis. These are 2C3 and 3 and 4. Total 4 C3 symmetry are present in the methane molecule. For better understanding, the top view of molecule, from the center of the molecule, the C3 axis is there. For better understanding, let's take some example for the tetrahedral molecule. CCl4, NiCO4, phosphate, SO42 minus, ClO4 minus. Next example of SF6 molecule. SF6 molecule has this symmetry elements. So the point group will be octahedral. Let's take some another example for the octahedral molecules. CrCO6, CONH3 3+ and COF6 3-. In case of SF6 molecule, 4C3, 3C4 and 6C2 axes are present. Let's discuss one by one. C3 rotational axis which pass from these two triangles. Such 4C3 are present in the octahedral molecule. Next, 3C4. This is one, this is second, and this is third. Total 3 C4 axes are present in the SF6 molecule. Next, 6 C2 are present in the SF6 molecule. First C2 and second C2 pass from, and this is third C2 and this is fourth C2. Fifth and 6C2. Total 6C2 are present in octahedral molecule. This is about symmetry elements of octahedral molecule. Next classification we will discuss in our further video lecture. Thank you.